Hello, and welcome to part one, the introduction, of building a silicon carbide radio transmitter for amateur radio. So, my name is John Rhines. I'm a retired U.S. Navy nuclear reactor operator who dabbles in electronics, and I travel quite frequently. And so, I thought, it's been a while since I've built something, so, let's build something new. So I sketched this up this morning. Now I'll bring it closer so you can see it. This is a Morse code radio transmitter for the 20 meter band, and it uses essentially three parts. So here is the signal source up here. Here is the MOSFET driver, gate driver, and the silicon carbide MOSFET right here. And down here is the output transformer and filter. It's a very simple schematic. Small, I should say. And down here is the keying circuit for the Morse code keys that will turn the voltage on and off for the oscillator to drive the gate driver. So, I kind of got inspired to do this transmitter from viewing recent salvage footage of the Titanic. Now, the Titanic was lost in, 1912, and radio was in its infancy back then. And the Titanic was one of the first few ocean liners to have a radio transmitter on board, and it saved so many lives. Now, back then, radio transmitters were very basic. They had, basically it was just a motor, a spinning motor, high voltage, and a few components like a capacitor, an inductor, and an antenna, and there you go, blast away. They were called spark gap transmitters. Well, over time, things developed. They had vacuum tubes as amplifiers, and they kind of cleaned things up. In comes the 1960s, and they have transistors for solid state devices. And solid state devices from there kind of took off. Well, in the last 10 years, they've come out with this new device, a MOSFET, a metal oxide semiconductor field effect transmitter, with a metallic gate in there, a silicon carbide layer on the gate of the MOSFET. Now, without getting too technically wonky, just for the engineers who can follow this, what that does is it lowers the gate capacitance it lowers the gate capacitance, period. And when you're using high frequency signals, such as those used for radio in the HF band, around 14, what I'm using is 14 megahertz, you can effectively drive these MOSFETs and produce a very powerful signal very easily. So I built one of these a few years ago, and I just used, there's basically the same schematic, but I used a regular MOSFET. I used an IRF 510, which is an N-channel MOSFET. And I got about 10 watts out using 13 volts as the power supply. Now, with silicon carbide, I should be able to, number one, these MOSFETs are capable of handling much more power. And I should be able to drive it even better at those frequencies because the gate capacitance is able to handle it. Now you may say, aha, for those of you who have caught this already, the IRF 510 is a linear region MOSFET, whereas the one I've chosen on this schematic is a switching MOSFET. And that is correct, but really, it doesn't matter. When I'm going to be driving this silicon carbide MOSFET, it is a switching transistor, to a switching MOSFET. It's going to be in the linear region for sure, but it doesn't matter because it's just capable of handling 900 volts at 10 amps, granted more efficiently, and I'm using 13 volts. That's the drain voltage supply. And it's going to burn some heat. It's not going to be 90% efficient. It'll be down there, but it's still, for radio purposes, it's going to put out a darn good signal. And being that large of a MOSFET, it'll be able to handle higher voltages and higher abuse on power. So I may be able to get 40, 50 watts out on one device, which is pretty darn good if I use like 45 volts on the supply. Anyway, the good thing about MOSFETs, and even these newer silicon carbide MOSFETs, is that the prices have come down significantly. So think back now. You're a builder back in the 1940s, 50s, or even 60s, and you're building a transmitter or an amplifier. You're using, saying, back in the day, a 3-1000 or a 4-1000 for an amplifier. And you make a mistake building, all of a sudden that big tube has to absorb so much current and so much power because you made a building mistake. Well, they'll take the abuse. Those tubes they'll let you know if something's wrong. They'll get all red and pussy, enough for you to look up and go, oh, and kill the power and or rethink things or see what you did wrong. Well, MOSFETs are, well, tubes have suggested guidelines. MOSFETs have ratings. You exceed that rating by just a millivolt, and they'll just explode and catch fire and shoot fire into the air, and they smell horrible. Well, the good thing is, they only cost like $3 each. You pop one out, you blow it up, oh well, just buy a new one. These silicon carbide ones are a little pricier. This one that I'm going to want to use is $7.50. But if I blow it up, I'll just chuck it in the garbage and get a new one. That's the beauty of modern day radio building, is that you can make mistakes. I don't really make mistakes because I've done this so much. I know what I'm doing. But if I were to actually make a mistake and blow it up, I'll just buy a new one. I mean, the DigiKey has 1,500 of this particular one in stock alone, so no biggie. Anyway, I hope you enjoy this video and the ones that I have coming in the future for learning how to build radio transmitters. And I should blow it up just to show you, but I know what I'm doing. Hey, catch you in the next one.